Yesterday we talked about what we would do with our partial fraction decomposition. That if you started with an equation that had a... All right, so we're going to first look at our denominator and see if it can be factored, right? Can this be factored? Yeah. Yes. Then we're going to factor it. So how would I factor x to the third minus 4x? What's the first thing you're going to do? Take out an x. All right, so we're going to take out an x, and when we take out an x, I get x squared minus 4. Can that be factored further? Yes, this becomes x times x plus 2 times x minus 2. So this is the first one we've done where we would end up with 3 terms, okay, which is the same process. It just requires extra work. So I'm going to separate these out. Each of those terms gets its own fraction. So this would be a over x plus b over x plus 2 plus c over x minus 2. Now the order there doesn't matter. I could have put the x plus 2 first and the x minus 2, but at the end, the right numerator should match with the right denominator. So the order doesn't matter, but which one goes with which obviously does. Okay, so now what's the next step?
You do the 3 parts and you put like for a...
What's going to be missing from each denominator, right? And this time it's going to be 2 things. So from A, I'm missing the x plus 2 and the x minus 2. From B, I'm missing the x and the x minus 2. And from C, I'm missing the x and the x plus 2. Now I ignore the denominators for the next couple steps. And I grab just my numerators. And I get x squared plus 12x plus 12 equals a times x plus 2 times x minus 2 plus b times x minus 2 plus c times x plus 2. And this time, instead of like trying to figure out what would cancel each one out, I think it's easier to go back to your original factored form, set these each equal to 0, and find the 3 things you're going to plug in for 0. Or plug in for x, sorry. So we're going to plug in 0. We're going to plug in negative 2. And we're going to plug in positive 2. With me so far? If you know what you're doing, you can eliminate a lot of the work. So I'm going to show you a couple tricks. First of all, you will always have to plug into the left-hand side. So there's no eliminating having to write out that left-hand side. That's fun. It would be 0 squared plus 12 times 0 plus 12 equals, so the left-hand side, you're always going to plug in your x. Now go to the right-hand side and think about what happens when I plug in 0 for x. Which of these will become 0 and go away? If I plug in zeros here, 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 and here, what's going to go away? B and C, right? Because they would both be multiplied by 0. So instead of writing those out, I'm only going to grab the one that would have stayed, which is A. So A times 0 plus 2 times 0 minus 2. So just eliminated a lot of writing. And then I'm going to keep going. 0 squared plus 0 plus 12 means 12 equals A times 2 times negative 2. 12 equals A times negative 4. And A equals negative 3. That's 1. Then I go to the negative 2. I'm always going to have to plug it into the left. So negative 2 goes inside the parentheses, squared. Let me get a darker one. Negative 2 squared plus 12 times negative 2 plus 12 equals. Now, if these are all negative 2, which ones are going to get canceled out? A and C, which means I'm going to keep B. B times negative 2 times negative 2 minus 2. And I get 4 minus 24 plus 12 equals B times negative 2 times negative 4. Okay, so this becomes negative 20 plus 12, negative 8. And this becomes B times positive 8, so B is negative 1. And then the last one I'm going to do is your 2, so it's still going to go in the left. 2 squared plus 12 times 2 plus 12 equals, if these are all 2's, what goes away? What becomes a 0? A and B. C is the one that's going to stay, right? So 2 minus 2 in A is going to become a 0, and 2 minus 2 on B is going to become a 0. So C is what's left, which we needed it to be 2 times 2 plus 2. And I get 4 plus 24 plus 12 equals C times 2 times 4. 28 plus 12 is 40 equals C times 8. And C is 5. And now I replace my numerators, and this is what I meant by order doesn't matter, but the right letter has to go over its matching denominator. So when you were to write this answer out, even if you wrote it in a different order, the negative 3 has to go above the x. So negative 3x is my first term. The b has to go over the x plus 2. Minus 1 over x plus 2 because we pull that minus out front. Plus the c has to go over the x minus 2. So longer process, but the same steps. You just have to extend it one more time. Questions on that process? Okay, if you were to get a fraction, I mentioned it yesterday, but I want to review it again. If you were to get a fraction, let's say A was 1/2. If I was to get a fraction as my numerator, then my 1/2, let's say it went over x. That 2, the denominator of my numerator, gets brought down to be the denominator with the denominator that's there. So this would be 1 over 2x like that. So if you have a numerator, let's say it was 1/2 in the numerator and it was x plus 2 in the bottom, this 2 comes out front, and this would be 1 over 2 times x plus 2. And you can leave it just like that. You don't need to distribute it. But you cannot leave the fraction within the fraction. Questions so far? Okay.